There's a black hole so massive that scientists don't think anything larger can exist. 100 billion times the mass of the Sun. Sitting at the theoretical limit of how big black holes can grow. Its event horizon spans 590 billion kilometers. Light takes over 3 weeks to cross it. Neptune's entire orbit would fit inside 23 times. And here's the twist. We may never find anything bigger. Not because we haven't looked, because physics says no more. Phoenix A. The cosmic limit itself. Phoenix A sits 5.8 billion light-years away at the heart of the Phoenix cluster, one of the most massive galaxy clusters ever detected. Discovered in 2010 by the South Pole Telescope. The cluster emits more X-rays than any other known cluster, 1,000 times more than typical clusters. That radiation comes from superheated gas spiraling toward the central black hole. For years, scientists measured star velocities, tracked gas movements, built models. The numbers kept climbing. 10 billion solar masses, 50 billion, higher. Final estimate, 100 billion solar masses. That dethroned Ton 618, the previous record holder at 66 billion solar masses. Phoenix. A is larger, quieter, not actively feeding, more evolved, settled into its maximum size. It grew mostly early, when the universe was younger, denser, and richer in gas. Now it sits at the edge of what's possible. Let's put Phoenix A in perspective. Sagittarius A, our Milky Way's black hole, 4 million solar masses, event horizon 24 million kilometers wide. M87, the black hole photographed by the Event Horizon Telescope, 5.4 billion solar masses. Phoenix A, 100 billion solar masses. Event horizon, 590 billion kilometers across. Place it where the Sun is. Mercury, gone. Venus, consumed. Earth, deep inside. Mars, still inside. Jupiter, at 778 million kilometers. Gone. Saturn at 1.4 billion, inside. Uranus at 2.9 billion, inside. Neptune at 4.5 billion, still inside. Keep going. Past Pluto. Picture this. The event horizon extends 100 times farther than Neptune orbits. 23 Neptune orbits fit inside. End to end. Light reaches Neptune in 4 hours. Light takes 3 weeks to cross Phoenix A's event horizon. This isn't a black hole. It's a cosmic abyss. Here's where everything changes. Yale astrophysicist Priyamvada Natarajan discovered something disturbing. Black holes can't grow forever. There's a limit, around 100 billion solar masses. As black holes grow, they radiate enormous energy. Matter spiraling inward heats up, generates X-rays, gamma rays, intense radiation. That radiation pushes back, blows gas away, prevents it from falling in. At a certain size, the radiation becomes so intense it shuts off the black hole's food supply. Growth stops. Natarajan calculated the limit. Right around 100 billion solar masses. The black hole starves itself. Its own energy output clears the surrounding space. Nothing can penetrate. She also found black holes eject powerful jets, beams shooting at near light speed. These jets plow through gas clouds, heat them, prevent cooling and star formation. No cooling means no material to feed the black hole. It's a feedback loop. The black hole grows. Its energy increases. That energy disrupts gas, cuts off supply. Growth halts. Phoenix. A sits at that limit, 100 billion solar masses, right where Natarajan predicted the maximum would be. If her calculations are correct, Phoenix A might be the largest black hole we'll ever find. Not because we haven't searched, because nothing larger can exist. The universe has a size limit for black holes, and we found it. Most black holes never approach this size. Why? Time. Phoenix. A formed billions of years ago, when the universe was denser, more gas available. Location matters. Phoenix A sits at the center of a massive galaxy cluster. Thousands of galaxies swirling around. More collisions, more mergers, more opportunities to consume other black holes. Brightest cluster galaxies are perfect environments. They're the biggest, most massive, most gas-rich. Phoenix A's host galaxy is enormous, elliptical, ancient, formed from multiple mergers, smaller galaxies colliding. They're black holes merging, adding mass each time. Most black holes exist in smaller galaxies. Less gas, fewer mergers. The Milky Way's black hole is 4 million solar masses, 25,000 times smaller. Phoenix A had billions of years of feeding until it hit the limit. Now it's dormant, slowly consuming whatever drifts close, never growing significantly larger. Phoenix A's event horizon is 590 billion kilometers across. Inside that boundary, nothing escapes. Not light, not matter, not information. Cross that line, you're gone. Forever. That boundary isn't a surface. It's empty space. Vacuum. You could fly through without hitting anything. But space-time is so warped that escape becomes impossible. The geometry of reality changes. Inside the event horizon, all paths lead inward. Every direction points toward the singularity. The way out doesn't exist. Even moving at light speed directly away from the center, you'd still fall inward. Space-time itself falls faster than light can climb. That's not a wall. It's a point of no return written into existence. The singularity at the center. All 100 billion solar masses crushed into a point of zero size. This is where the math stops working. Our equations break down. We no longer know what actually exists. But here's the final twist. Phoenix. A might already be dead. Its light takes 5.8 billion years to reach us. We're seeing it as it was 5.8 billion years ago. Something might have happened. A collision, a disruption. We won't know for 5.8 billion years. Information travels at light speed, no faster. Phoenix A exists in our past. A fossil, light that's been traveling since before Earth formed. And somewhere in space, other ultra-massive black holes are growing, approaching the limit. We just haven't seen them yet. Phoenix A, 100 billion solar masses. The largest black hole we've ever found. And possibly the largest we'll ever find. Sitting at the theoretical maximum, its event horizon spans 590 billion kilometers, takes light 3 weeks to cross, contains 23 Neptune orbits. It formed through billions of years of mergers, growing until it choked off its own food supply. Now it sits dormant. Priyamvada Natarajan showed us the limit. Around 100 billion solar masses, where black holes starve themselves through their own radiation. Phoenix. A might prove she was right. The universe has boundaries. The largest star, the fastest speed, coldest temperature, and now a most massive black hole. In the universe that seems infinite, even unimaginable objects have limits. Subscribe for more cosmic extremes and deep space exploration. Drop a comment. Which cosmic record would you like to hear about next? The universe has monsters, but even monsters have limits.